So what happened though? So this is big data is a big transition, right? That's how I see it. That in the beginning, in the 80s and 90s, uh, before the internet revolution, right? And this slide is from a class I teach here internally, so that's why you don't see updated any dates or anything. So what happened? The way I see it, this is my own language. I'm not reading from any script. What I saw, what I think in the 80s and 90s, and even in 2000, before the internet revolution, uh, the data processing needs were for a corporation were very restricted or had a small need where people had their finance systems, people had their CRM systems, people had their HR systems, transactional systems, and very often than not, those systems were doing fine for the purposes of capturing sales, capturing HR transactions, capturing marketing events, and so on and so forth. And a relational database, for all practical purposes, was adequate to take care of that business need. Later on, as you know, Shrikant, that it was the so that was called the OLTP revolution, the online transaction processing, and which gave birth to the relational database uh, structures, and basically the revolution into the digital world for most companies happened aligned with the prominence of relational databases. And relational databases like Oracle and SQL and DB2, they were great. I mean, businesses were able to capture their business events, be it sales or marketing, HR, and so have you. And later on, people also wanted to start getting into analytics. When you're capturing, say, point of sale, businesses wanted to know that, hey, how much, classic analytics use case, that how much of this we are selling versus others, and which ones are my top 5 things I sell in the Northeast region versus some other region, what's my year-over-year store sales, where are my vaccines, if I'm vaccines manufacturer, where are my vaccines, where are the most possible cases of vaccines people will be needing, so I can ship my vaccines early on so people who will need it will have it. So those analytics needs emerged, and which gave rise to what we back then we called the OLAP systems, right? Online analytical processing. And those were, it was well understood at that point that the transactional processes which were recording your transactions in your OLTP systems were probably not the best systems to do this analytical work, because of a lot of the way the indexing was working, the way the locking was working, and the way the systems were structured more into writing. So the OLTP systems were predominantly optimized towards data being written very fast, and then about the ACID transactions. Once you write to a database, it was very important that it stays there, right? If you're, if you're recording your company's event, sales event, something, a point of sale system, you had some transaction. You want the transaction to go into the database, and you didn't want it to go anywhere, right? So it was clear that the need for the analytical processes or the systems you would need for analytical processes were different than the classic need to write, the transactional systems you needed. So that gave rise to the OLAP processes. This is, I'm talking late 80s, 90s, and then various types of technologies emerged. And a very common one, you may have heard, that how people did cubes. They would pre-create these large analytical cubes, excuse me, with all kinds of possible dimensions by which you want to see your data, be it by geography, be it by time, be it by product, be it by your categories, be it by customer segment, so on and so forth. Those would be the dimensions of a cube, and the facts, like your sales, uh, will become you'll be able to slice and dice the cube to get your facts by any of those various dimensions. And life was good. Lots of billions and billions of dollars were invested by various companies into setting these OLAP systems, which were a copy, which would periodically copy data from an OLTP system overnight as a batch process, and things were good. And a lot of us, including myself, we spent a lot of a decade setting up those systems and making sure the businesses had the reports they needed so they can make the decisions they need to make to continue the business, right? Then something interesting happened. Internet was born. Came internet, right? And with the internet came, you know, the Googles and the Yahoos and all the related things, and the data, the amount of data which was being created just exploded. It just exploded beyond any business who had established OLAP or OLTP system could ever keep track of. Now that everything is being written, any website's being traveled, every time someone clicks on it, clicks a button or anything, there's a log of that, right? There's a web log, Apache log. Anytime someone buys something, there's a record of that. Anytime someone uh, sends an email, sends a Facebook thing and a Twitter, a log is being generated, and but the traditional systems, though, which we had, I had, and Nilima and you and Dr. Srini, we had helped create those OLAP, OLTP systems, were nowhere capable of storing this huge amount of data, right? That was being generated by websites and this and server logs and your uh, monitoring equipments and your hospital sensors. There was just no way. It was not designed. These data sets were not relational, as you could imagine. And so obviously the relational databases were not a good fit to store that data. And also the volumes were just too vast. It was just too much coming at you too fast. So, so if you see in this slide, uh, that 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 in the once the internet was invented, the gap between the current systems, which could data processing systems, and the need of the business, it just got just wider and wider, and there was no way that traditional systems could have kept up with that with that uh, with that amount of volume, and so that gave birth to. This is now we're talking about. We are in mid 2005, that kind of time frame. Uh, Yahoo was trying to crunch their weblogs of daily weblogs, and they were having trouble just fitting everything in one machine because the data volumes were too huge, and Google in parallel were having the same problem. And so they understood, some of the smart engineers, and there was a actually Indian engineer at Yahoo, Atul, someone, right, Nirima, and he had a major role in that. And what they figured that putting everything, all these data in one big machine and processing it all at once, that was just not going to work for them. It was, they figured that was just that kind of methodology, which had served the corporate business for 2 decades prior, that there's no way that was going to work for this because the volume, it was just too much. So they knew they had to do something different. And this was about the same time uh, Doug Cutting and others working at Yahoo, and they came up with this idea of basically parallelizing the input, right? So they understood what they came up with an idea that instead of putting everything in a huge machine, right, huger machine, it makes more sense to break that job. Suppose you have 100 million weblog records, to break the job into parallel chunks and have individual machines, which are much smaller. They are not your top line Teradata Oracle machine servers, right? These are your regular commodity machines. And they figured that just by parallelizing the work on commodity hardware, as it's called, you know, just some small server with, say, quad CPU and a bit of RAM and disk, just your standard server could, but a whole bunch of them could process the data much easier than you would if you had to shove all the entire data set into one big machine and wait for the entire batch to process before you start doing queries.